The PLA Air Force's H-20 stealth bomber has triggered ridicule from senior U.S. military officials. At the press conference on April 22nd, a Department of Defense intelligence official said, "The thing with the H-20 is when you actually look at the system design, it's probably nowhere near as good as US low observable platforms, particularly more advanced ones that we have coming down. They've run into a lot of engineering design challenges. In terms of how do you actually make that system capability function in a similar way to like a B-2 or a B-21? It is well known that the US military is adept at exaggerating the strength of its adversaries, especially when facing strategic competitors like China and Russia, often exaggerating their threats to secure more military funding from Congress. However, this time facing China's still nascent H-20, senior US military leaders have expressed such disdain so openly. It can be seen how insignificant the H-20 is in the eyes of the US military, not even qualified as a boogeyman to scare taxpayers. Previously reported by CCTV, compared to the US-made B-2 stealth strategic bomber, the H-20 has a maximum takeoff weight of 200 tons compared to 170 tons for the B-2, a maximum fuel capacity of 130 tons compared to 75 tons, and a maximum payload of 45 tons compared to 22 tons, almost surpassing the B-2 in all these key aspects. Let's first take a look at its stealth capabilities. In the H-20 project, China once considered two technological routes: subsonic stealth and supersonic. Initially, it was more inclined to emulate the subsonic schemes of the B-2 because China had accumulated considerable aerodynamic experience with its UAV Rainbow 7, UCAV-8, and UCAV-11 flying wing layouts. China has also developed various anti-stealth radars such as VHF, UHF, and L-band to test the H-20. In 2016, China successfully developed the H-20 prototype and conducted wind tunnel test and test flights. Subsequently, engineer coated the prototype with stealth coating, and a research institute in Nanjing specializing in anti-stealth radars tested the H-20 prototype with various anti-stealth radars. All kinds of anti-stealth radars were tested, and it was found that the H-20 prototype was blatantly visible on the radar screen, with stealth performance far below the designer's expectations. How bad is it? According to a study published in a paper, the B-2's radar cross-section RCS is hard to exceed -10 decibels in 1 meter wavelength radar waves, which is at the lower end of very high frequency, appearing as a tennis ball sized target on the screen, about 100 pixels wide and 100 pixels high. The more advanced B21, its RCS is this band, is at least -20 decibels, about 10 times 10 pixels. The stealthiness of the H-20 is at least 0, which is 1000 times 1000 pixels. With such a level of stealth, the H-20's battlefield survival capability is worrying, let alone penetrating the United States. This is also the fundamental reasons why the H-20 has been unable to appear for so long, failing to match the stealth capabilities of the B-2 from 30 years ago. Although the stealth details of the B-21 are not directly relevant to this topic, understanding its stealth capability is crucial for recognizing the technical challenges facing the H-20. This video will combine some lesser-known information to provide a detailed introduction to the B-21's stealth performance. Why is it so difficult to replicate the B-21? The B-21 boasts full-band stealth capabilities, with its sleeker and smoother design reducing radar cross-section area compared to the B-2, making it difficult for even giant radars from calibers as high as 900 to 1,100 millimeters to detect its presence. Whether observed from the front or above, this means the B-21 can easily penetrate the Arctic Eye radar in Alaska, Russia's radar, China's Skynet radar used for monitoring airspace and tracking incoming missiles, as well as Europe's defensively deployed air defense radar network. Even radars operating in the very high frequency millimeter wave band, which are claimed to be the most effective against stealth targets, struggle to pose a substantial threat to the B-21. These radars use resonance effects generated by aircraft wings, nose cones, and intakes, amplifying target echo signals by 10 to 40 decibels. However, the B-21's simple design and key component sizes larger than the wavelength of VHF radar make it difficult to generate significant resonance effects, maintaining its stealth advantages. Advanced air combat systems such as shipborne PLA band large aperture phased array radars, airborne fire control radars, and 200 caliber missile-borne radar also struggle to exhibit the necessary detection and tracking capabilities against the B-21. China's active semi-active radar-guided air defense missiles such as the Red Flag 16 and radar-guided air-to-air missiles equipped with a 160 caliber missile-borne radar also find it challenging to lock onto the attack, the B-21. Analysis suggests that currently only certain new ground-to-air missile equipped with large caliber radars and ample energy, such as the 40N6 type long-range missile in the Russian S-400 system, have the potential to threaten the B-21, but this missile type has not yet entered service. Specifically regarding the Chinese Air Force, bringing down the B-21 can be described as extremely challenging. Aircraft-mounted X-band fire control radars carried by Chinese fighter jets are almost incapable of detecting the B-21 in complex electromagnetic environments and can only continuously attempt to approach the B-21 based on target data provided by ground or early warning aircraft. If Chinese military aircraft attempt to approach the B-21 and launch attacks using infrared-guided missiles, they will be countered by the B-21's advanced infrared-guided air-to-air missiles. It is worth mentioning that the B-21 missiles are highly flexible in target positioning and attack angles, able to launch attacks as long as they are within the visual range of the aircraft pilot, even with inverted launches ensuring precise target hits. With limited options, Chinese military aircraft may resort to deploying Mad Dog missiles. In this mode, missiles can only fly in a straight line, targeting whatever is in front, be it friend or foe, which easily leads to friendly fire accidents. Therefore, before launching Mad Dog missiles, it is necessary to repeatedly confirm that there are no friendly aircraft within a corridor about 20 kilometers wide and 200,000 meters high in front of the missile, making it almost impossible for practical combat use. At best, this strategy can only be used for intimidation. Millimeter wave fire control radars still lack the detection accuracy needed to independently achieve shooting down stealth targets. Although advanced millimeter wave radars can provide the required fire control accuracy, they are limited by antenna size and cannot yet be used on fighter jets or air-to-air missiles. According to computer simulation results from a certain military forum, Chinese J-10C fighter jets equipped with advanced PL-15 medium-range air-to-air missiles can only continuously lock onto the B-21 within 55 kilometers under the guidance of phased array radars on the O-52D destroyer and the KJ-500 early warning radar. By the time the B-21 enters this distance, it has already destroyed the J-10C fighter jets, 052D destroyer, and KJ-500 with its own missiles. Is China capable of replicating such an advanced aircraft? Looking at the experience of replicating Patriot missiles in Taiwan, even with direct technical support from American companies, the performance of its finally developed Skybow air defense missiles could not reach the level of the Patriot 2. It can be inferred that without US technical support, completely replicating the B-2 is impossible. Even for a military power like the United States, it took 20 years from the initial concept of the B-21 to its current flight testing and production. China confirmed the existence of the H-20 in 2016, and now, just after 8 years, how could they feasibly develop something substantial? According to information from a certain military forum, due to the stealth performance consistency falling short of expected targets, the H-20 project has been stalled since 2016-2017. Failing to obtain cutting-edge stealth coating technology from the United States, China had to explore other avenues. Rumors has it that after the project came to a standstill, a leader in the military industry complex discovered that Longshan, a company specializing in automotive components, had developed automotive paint with excellent radar wave absorption properties. If cars were coated with this paint, they would be undetectable even when speeding. Since 2017, Longshan has transformed into optical star technology, focusing on developing and producing cutting-edge equipment using metamaterials. However, radar speed measurement generally targets speed ranging from 24 km per hour to 200 km per hour, while the company's research and development achievements need to be applied to strategic bombers with speeds exceeding 1,000 km per hour. Thus, the effects of absorbing radar waves may not be satisfactory. Turning to supersonic flight. Considering the current inadequate stealth performance, China may turn to developing supersonic bombers. However, there is a contradiction between supersonic aerodynamic design and stealthy shapes, making it difficult to balance the two. Supersonic flight requires sharp noses and thin wing designs to reduce drag, while stealth requires smooth shapes to reduce radar cross-section. Even if a prototype is barely produced, achieving supersonic cruise and stealth large payload would still require turbofan engines. Turbofan engines operate in turbojet mode at low speeds and supersonic mode at high speeds, making them the ideal power source for achieving hypersonic flight. However, these engines are still in the experimental research stage. Engines. In addition to insufficient stealth capabilities, the engine of the H-20 are also a major challenge. Initially planned to be equipped with so-called Taihang engines with thrust up to 18 tons. The total power was claimed to far exceed the B-2's 34 tons. However, this engine not only faced delays but also failed to achieve the desired single nozzle thrust and had remarkably high fuel consumption, failing to meet military standards. To achieve good stealth effect, the engine, fuselage, and intake must be integrated into the design, which would occupy more internal space, limiting the volume of fuel tanks and bomb bays, thereby affecting the H-20's range and payload. Coupled with China's perennial issues of high fuel consumption in engines, equipped bias, and large missile volumes, achieving the originally set maximum takeoff weight of 200 tons, maximum fuel capacity of 130 tons, and maximum payload of 45 tons seems difficult to realize. Currently, the H-20 can only make do with the so-called domestically produced EMA Turbofan 15. However, this imitation of a Russian-made engine has a single thrust of less than 12 tons, and even though the total power of the four engines exceed 34 tons of the B-2, after flattering and system optimization, the thrust is less than half of the B-2's, making it impossible to support the H-20's 200-ton bulky body. Moreover, the EMA engine is unreliable, burning oil like water, and it is possible that the H-20 would have to make an emergency landing halfway through its journey. After the parameters of the American B-21 were released, the H-20 had to follow suit and strengthen its data link, informalization, collaborative combat capabilities, and even added new requirements such as onboard lasers and active defense midway. This again raises higher power generation requirements for engines, and the WS-15 under development is difficult to meet the requirements, requiring a restart. Otherwise, producing an H-20 inferior to the B-21 would disgrace the Chinese military. Therefore, in 2016, China turned its attention to the C929 project, hoping that cooperation with Russia on this large-scale passenger aircraft project will enable Russia to provide engines for the H-20. But breakthrough progress has yet to be made. Weapons systems. The weaponry aspect is also a weak spot for the H-20, considering that the CJ-20 long-range cruise missiles and the DF-21 ballistic missiles are China's main models for maritime attacks. They could become the primary armaments for the H-20. However, both of these missiles fall short in terms of range, accuracy, and penetration capabilities. While the DF-21 is China's first true air-launched ballistic missile, it lacks the ability to maneuver and evade interception once launched. Even more concerning is its limited capacity to carry outdated conventional warheads, far less powerful than the US's hypersonic nuclear missiles, the Minuteman III. Consequently, even if the H-20 manages to breach US defenses, it is unlikely to inflict significant damage on the likes of the Nimitz-class carriers. Moreover, as a strategic bomber, the necessity of carrying air-launched nuclear weapons is yet to be determined. China awaits the maturity of its scramjet technology to power their hypersonic glide vehicles, at which point the size can be finalized. This aspect of the project's delay is another reason why the H-20 has yet to make its debut. Additionally, current hypersonic glide vehicles are too lengthy to be accommodated within the H-20's bomb bay. Cost. The Chinese Air Force has been indecisive and fickle in managing the H-20 project, often changing its directives. Originally, the H-20's design was a replica of the B-2's flying wing layout. However, since acquiring the specification of the US B21, the Air Force leadership fears that the H-20 might become obsolete upon its introduction. Consequently, from stealth designs to information systems, benchmarks have been repeatedly revised, leading to delays and skyrocketing costs. This vacillation not only delays the H-20's development, but also leads to significant budget overruns. Drawing from the experience of the US B-21 radar bomber project, as development progresses, the unit cost may escalate from the initial $600 million to $700 million or even higher. Considering China's incomplete autonomy in key technology domains and the uncertainty stemming from a lack of accumulated combat experience, a final unit price for the H-20 between $800 million and $1 billion is not out of the realms of possibility. Even in times of economic prosperity, it would be challenging to persuade the military to foot the bill for such exorbitant spending. However, with the sudden increase in downward pressure on the Chinese economy, sustaining projects like the H-20, which are synonymous with burning cash, is uncertain. Although the military recognizes the importance of strategic bombers, it's unlikely to prioritize the H-20 over investments in more tangible assets like additional Type 055 destroyers, 1 or 2 aircraft carriers, or replacing outdated J-7 and J-8 fighters with J-20s. Restricted by key technologies. The Chinese military's stance on the H-20 is growing increasingly cautious due to its reliance on critical technologies. Even if the H-20 project is extended, it is inevitable that the development cycle will lengthen and the scale of deployment will shrink. In 2016, General Ma Xiaotian, the former commander of the Air Force, publicly acknowledged China's development of a new generation of long-range strike bombers. In March of this year, Lieutenant General Wang Weijing, the deputy commander of the Air Force, further revealed in an interview that the H-20 would soon be unveiled. When asked about rumors of technical bottlenecks facing the H-20, Lieutenant General Wang confidently responded, "There are no bottlenecks. Everything can be resolved." When senior officers discuss equipment not yet in service in public, their statements may not fully reflect the actual situation due to considerations of secrecy and propaganda. Expressions like "there are no bottlenecks, everything can be resolved" primarily convey a sense of confidence and determination rather than serves as a definitive proof of smooth progress in the H-20's development. In fact, the H-20 has yet to be publicly unveiled, which likely indicates that its performance has not yet met the Air Force's requirements. China's Air Force has only one hypothetical adversary globally, the US Air Force and Navy, which undoubtedly have stringent requirements for new strategic bombers. It is speculated that the original H-20 scheme resembles that of the US B-2 bomber, but this plan was overturned between 2017 and 2018. It is expected that the H-20 will not make its maiden flight until between 2027 and 2030. Its formal commissioning may not occur until after 2030. While the H-20 represents a certain ambition for China in strategic military hardware, its prospects are not optimistic in the current context. Whether its stealth capability, information systems, or weapon effectiveness, this bomber, which claims to break the US military's monopoly, is unlikely to challenge the established status of the B-2, let alone vie for the throne against the B-21. The significance of the H-20 probably lies more in strategic deterrence and political propaganda than in preparing for actual combat needs. Even if it's eventually commissioned, it may only serve as an expensive and useless decoration, merely a bargaining chip for China in its contest with the US. Although there is uncertainty about whether the H-20 will meet its expected targets, its reflection of industrial ambitions and international aspirations remains a cause of concern. To uphold the rules-based international order and restrain China's expansionist impulses, the US and its allies must continue to maintain comprehensive superiority over China, ensuring that they dare not act recklessly under the shadow of the H-20.